the third and last problem in our third categorical logic homework, the one on categorical syllogisms, comes from section 5.2, problem set 1, problem number 20. Our instructions here tell us, use Venn diagrams to determine whether the following standard form categorical syllogisms are valid or invalid. In some cases, validity depends upon whether the Aristotelian standpoint can be taken. Indicate validity or invalidity of the argument for each logic, Aristotelian and Boolean. Then identify the mood and figure. Cross-check your answers with the list of valid syllogisms found in section 5.1. Argument 20 is as follows. Some snowflakes are not uniform solids. All snowflakes are six-pointed crystals. Therefore, some six-pointed crystals are not uniform solids. So our first task will be to evaluate the argument for Boolean and Aristotelian validity using our Venn diagram technique, our effective decision procedure. So to use our Venn diagram technique, we start off by drawing our three-circle diagram, one for each of our major, minor, and middle classes. We label it as a premise diagram. The minor term, the subject to the conclusion, always goes in the bottom left. The major term, the predicate of the conclusion, always goes in the bottom right. In this case, our minor term, six-pointed crystals, so I use C. Our major term, uniform solids, so I'll use U. Our middle emerging term, the one that's in both premises, always goes in the circle on the top. As so. Then we need to draw a conclusion diagram. Again, all three circles, label it conclusion, minor term, six-pointed crystals, subject to the conclusion, bottom left, major term, uniform solids, predicate of the conclusion, bottom right, middle term, term that's in both premises, snowflakes, S, up top. Now that we've got our diagrams, we want to fill in what has to be true in order for both of our premises to be true, and then what has to be true if our conclusion is going to be true. So we'll start with our premises. We'll start, as always, in Boolean logic, and we'll start, as always, with a universal categorical statement, always starting with universals, then doing particulars. If we have more than one universal, we just choose one. If there's only one, we always do that one first. Our premises here have one universal statement, our universal affirmative, minor premise, that second premise. All snowflakes are six-pointed crystals. So now we start off, we're being good Booleans. We don't know if there are any snowflakes. We don't know if there are any six-pointed crystals. But what we do know is, in order for this premise to be true, everything in that S class, everything in the snowflakes class, if there is anything, it has to also be in the six-pointed crystals class, because all the snowflakes, if there are any, are six-pointed crystals, if there are any. So that tells us that if I'm in the snowflake circle, but I'm not in the six-pointed crystal circle, I have to be empty. And so we will shade in to indicate that that area has to have nothing in it, both S and only S, and S and U. Both areas in that S circle, outside of the C circle, have to be empty if all of our snowflakes are six-pointed crystals. Now we go to our particular premise. That's our major premise, the first premise. Some snowflakes are not uniform solids. We read that sum as there's at least one thing. It is a snowflake. It's in that S circle. It is not a uniform solid. It is outside of that U circle. So there is an X. It's in S. It is not in U. And the only place we can put that S, or that X rather, in S and outside of U would be in that area that is in C and S, but not in U. So we write our X in just like that. Now we go to our conclusion diagram. Our conclusion is a particular negative statement. It says some six-pointed crystals are not uniform solids. Again, there's at least one thing. It's in the six-pointed crystal circle. It's inside of C. It is not inside of U. It's not in U. It is in C. There are two places in that C circle where an X could go that are not inside of U. There's the S and C area, and there's the only C area. Nothing about this conclusion dictates one or the other area. So we know we can't put it in either one exclusively because that's more information than we'd have. We put it in the S and C circle area here, this area right here, then we would be saying it is an S, that's a snowflake, it is a C, a crystal, six-pointed crystal, and it's not a U. But the conclusion doesn't require that. It says as long as you're not a uniform solid, but you are somewhere else in our six-pointed crystal circle, either here or here, then I'm fine. So if we put it up here, that's more information than has to be the case in order for the conclusion to be true. So whenever we have more than one area like this, then we want to put our X on the line between those areas. Now it says there has to be an X. It is in C, six-pointed crystals. It is not in U, uniform solids. It might be an S. It might be just in C. Either way makes it true. So now we say, okay, in order for my conclusion to be true, I have to have an X somewhere in C outside of U, either here or here, guaranteed if my premises are true. I go over to my premise diagram, I look at that area, and I say, okay, I've got an X in S and C when I make my premises true. If the premises are true, the world is such that there has to be at least one thing. It is a snowflake and a six-pointed crystal. That's one of the ways to guarantee this conclusion is true. And so as a result, my argument is valid. Since it's in Boolean logic, it is valid in both logics. It's unconditionally valid. The next part of our instructions tells us that we should identify the mood and figure for the syllogism, check it against the list, and verify the conclusion that we got with our Venn diagrams. So we look at our first premise, the major premise, that is some snowflakes are not uniform solids. That would be a type O, a particular negative. Our minor premise says all snowflakes are six-pointed crystals. That is the universal affirmative, a type A statement. So we've got O, A, and our conclusion says some six-pointed crystals are not uniform solids. That is a type O. So we've got an O, A, O for the mood of that argument. Major, minor, conclusion. For our figure, we need to look and see where the middle term is, the term that's in both premises. That term in this argument is snowflakes. Snowflakes is in the subject of the major and the subject of the second, the minor premise. So it's in the subject slot in both premises, and that would make it a figure 3. Figure 1, subject of the major, the first premise, predicate of the minor, the second. Figure 2, predicate of the major, the first premise, predicate of the minor, the second premise. Figure 3, subject of the major premise, first premise, subject of the minor premise, the second premise. So it is a figure 3. We check on the list for OAO3, and sure enough, it's listed on the chart of unconditionally valid arguments, and so it is in fact valid in both logics.